Okay, so today we are talking about something called combinations. Before spring break, we talked about permutations. And permutations, if you'll remember, I gave you that example of you go to your locker, right? You go to your lock, and you put in 3 numbers, and they have to be in a specific order, okay? Do they work if you put them in a different order? No. And so I told you your locker combination should mathematically be called what? A locker permutation. So what is important about a permutation? Order matters, okay? The order of your items matter. A combination is the opposite. A combination order does not matter. So you've got this definition on your piece, on your notes, okay? Combinations is an arrangement of R objects without regard to order, okay, and without repetition, selected from n distinct objects. This is called a combination of n objects taken R at a time. So, for example, let's say we've got 20 people in here, all right, and I need to pick 2 class representatives. Okay, 2 class representatives. It doesn't matter who I pick first or second. I just need 2 representatives. Is that a combination or a permutation? Combination. We're choosing 2 people from 20. So that would be 20 choose, just like our big P was our permutation, 20 big C 2. Okay? If I wanted to pick a president and a vice president from our class, then does order matter? Yeah, so then we would do a permutation. Okay? Permutation, order matters. Combination, order does not. So here's your equation for a combination. We said 20 choose 2. Okay? This would be N choose R. Okay? You hear me say that C as choose. Okay? It means combination, but often that C, for some reason, connects with teachers, professors, wherever, to be choose. So you'll hear me represent that C as the word choose. Okay? So we've got n factorial over n minus r factorial times r factorial. How is this different than the formula for permutations? Yeah, the denominator is being multiplied by r factorial. A permutation just is n factorial over n minus r factorial. Why now in a combination do I again divide out by r factorial? Why do you think? What is r representing? Yeah, the number of things I'm picking, okay? What does r factorial represent? Kind of. What do you mean by options?
Like, because if you do the factorial thing of r, then it tells you how many arrangements there are.
Yeah. So the r factorial are the arrangements of those r options. So why am I dividing that out? Do I care about the order of my r options? No. In combinations, order does not matter. Okay? Guys need to wake up and get with me here. Okay? I see a lot of dozing eyes. All right? The reason we divide out by r factorial is because we don't care how many different ways we can arrange the R items that we've picked, because order does not matter. I don't care if I choose person 1 first or last. He still gets picked to be in my committee or my representative. Okay? All right, so just to kind of reiterate, in permutations, we're counting all our different arrangements. Okay? The way we arrange books on a shelf, the way we arrange different coats, all that stuff. Combinations, we are counting groups. The order does not matter. That R in the denominator means we're dividing out the same elements that are considered different in permutations, but not in combinations. Okay? All right. So, we did this last week, okay? We wanted to write out all the different ways we could pick 2 letters from 4, from A, B, C, D. And we wrote out all of these. Do these represent permutations or combinations? Permutations. Why? Yeah. We've got AB listed up here, and we've got BA listed up here as 2 different things. So how many permutations do we have? 12. There are 12 things written up there. Do you think we have more or less combinations? Less. Okay? What am I going to have to cancel out in order to count all my combinations? Yeah, all the reversals or the repeats. So I have to count all of those out. So how many combinations do I have? 6. All right, any questions? All right. In a conference of 9 schools, this is on your notes, in a conference of 9 schools, how many inter-conference football games are played during the season if the teams all play each other once? Okay, they each play each other exactly once. Is this a permutation or a combination? Combination. Why? Yeah, it doesn't matter if I play Ben or if Ben plays me. We're still playing a game together, right? That order doesn't matter. We're each only playing each other one time. So in terms of combinations, how could I do this? What are we choosing? No, we're not picking. We don't want them in groups of 9. Groups of 2 from those 9 teams. So I'm about to click this, and a lot is going to come up here, but just kind of hang with me, and we're going to work our way through it, okay? So 9C2. What that represents is that I have 9 teams to choose from, and I'm picking groups of 2. I want to know how many different groups of 2, how many different games can be played between 2 teams. Okay, so does that part make sense? 9C2. All right, this next step right here, what have I done here? Yeah, I've just plugged it into my combinations formula. 9 factorial over 9 minus 2 factorial times 2 factorial. All right? The next step, I have just simplified 9 minus 2 factorial as 7 factorial. Okay? All right. Let's talk about how do I get from 9 factorial times over 7 factorial times 2 factorial to 9 times 8 over 2 times 1. What have I done? No calculator involved. Canceled out. Okay, so let's think about this. 9 factorial. Would you agree that for 9 factorial I could write 9 times 8 times 7 factorial? Do you agree with that? Because 7 factorial is just 7 times 6 times 5 times 4 times blah, blah, blah. Okay? All right, and then on the bottom, I have 7 factorial times 2 factorial. So what happens with my 7 factorials? They cancel. 2 factorial is the same as 2 times 1, and thus we are left with 9 times 8 over 2 times 1. All right? And we get 36. What if the order did matter? Each team got to be a visiting team one time, and each team got to be an away team one time. What would your answer be then? 72. Because the only thing that would be different in our equation is we wouldn't have this 2 factorial. We're dividing out that 2 factorial because the order doesn't matter in this case. Okay? All right. And then, oh, like I said, you'll hear me say 9 choose 2, or professors say 9 choose 2. It's just another way to talk about this. All right, so to our calculators. Let's type this in so we don't have to go through that math each time. Same place as permutations and factorials. Okay? So, math, arrow over to PRB. And instead of choosing NPR, we're going to use NCR. So go ahead and type that in. Make sure you get 36. Once you've done that, I would like for you to try 9, choose 7. What happens? It's the same thing as what? Yeah, as 9C2. Why? Is that just a coincidence? 7 plus 2 is 9, but why does that make it work? Okay, so if I have 9, choose 7, factorially, what does that look like? What's on top? 9 factorial over 9 minus 7 factorial times what? 7 factorial. What does that simplify to? 9 factorial over 2 factorial times 7 factorial. Does that look the same as the one we just did? Yeah. This is not a coincidence. This will always happen. Okay? The idea is that if you're choosing 7 things from 9, that's the same as choosing which 2 to leave out. Choosing 7 to be in, you're choosing 2 to leave out. It's the same idea. So anytime you've got numbers that add up to what you're choosing from, they should be the same. So 25, choose 5, and 25, choose 20 should be the same numbers. Does that make sense? All right. Let's go to some examples. Let's talk about this card problem you'll see next. You're going to draw 4 cards from a standard deck of 52 cards. How many different 4-card hands are possible? Is this a combination or a permutation? Combination. Why? Right. When you're picking a hand of cards, it doesn't matter what order you were dealt those cards, okay? It's not like Hold'em or something like that, all right? Just matters what's in your hand. So how would I do this? Go ahead and give it a try. You can use your calculator. You don't have to write it out factorially. Mathematically, what are we going to do? Okay, we're going to do a combination, and it's going to be what? C what? 52C4. And what'd you get? 270,725. Are you surprised? No? A little bit? I don't know. Sometimes you don't think there's that many different options, but there is. All right. What is the probability your hand will be the 4 queens? How many hands are going to have 4 queens in it? 1. How many total hands are there? Yeah, so what's the probability going to be? 1 over that number. What if we wanted to work this like our old probability questions? Could we? Yeah. So if we wanted to work this like we had done in the past, what's the probability of picking your first queen? Okay, 4 out of 52 or 1 in 13. What's your probability of picking your second queen? 3 out of 51. Then 2 out of 50. 1 over 49. And if you were to work this out on your calculator, you would end up with the same answer. Okay? It's a little trickier because when you try and math frac this, your calculator doesn't really like it. All right. Okay. We've got a lot of marble type questions that you'll see. These type of questions will come up a lot, homework, things like that. All right? 3 marbles are drawn at random from a bag containing 3 red and 5 white marbles. All right? How many different draws are there? And that word draws just means groups of 3 marbles that we've picked. Okay? All right. How am I going to figure this out? Okay, we're going to do a combination. Why are we going to do a combination? The order doesn't matter. So what choose what? 8 choose 3. Do it on a calculator and see if it matches. Did you get 56? All right, good deal. All right, how many different draws would contain only red marbles? Now just logically think about this question for a moment. How many different draws will contain only red marbles? 1. Why 1? Yeah, there's only 3 marbles. So there's only one way I can get all 3 of them when I pick 3 marbles. Okay? So logically, yes, that's exactly how you would think about this. Let me show you mathematically just so it'll help us prepare for other questions. Okay? This is 3C3 times 5C0 equals 1. Now let's talk about where I get these numbers. Okay? This 3C3 represents my red marbles. Out of 3 red marbles, I want a group of 3 of them. I'm choosing 3 red marbles from 3. Okay? So if I do that, that means how many white marbles can I be picking? 0. So that's why this is 5, my number of white marbles, choose 0. All right, what does this tell us about 3C3? What must that be equal to? 1. 3C3 has to be 1. You think that's true anytime you have the same number? Yes or no? Yeah. Okay. Anytime you have k elements and you want a group of all k of them, there's only one way to do that. Okay? All right. What does that mean about 5C0? 5C0 is equal to what? 1. How many ways are there to choose 0 objects from 5? Just 1. Okay? Anything choose 0 will always be 1. Anything choose 0 will always be 1. Questions about that? All right. What is the probability then? I'm still on part B. What is the probability then that you would draw only red marbles? 1 out of 56. It happens 1 time out of a total of 56 times. So even though you don't have this on your notes, I would definitely write this down because a lot of your homework questions don't say how many. They say what is the probability. So I'd make sure you're marking down about our probability questions here. All right. 3 marbles are drawn. Same problem. How many different draws would contain 1 red and 2 white? 1 red and 2 white. Ideas on how we could approach this? Nah, we're not going to do that. Good. 3C1, 3 red, and we're picking 1 of them, and 2 white. 5 white total, and we're picking 2 of them. So 3C1 times 5C2, and we get 30. I'm sorry? Why the 2? Because I'm picking, I want 2 white marbles. So I'm choosing 2 white marbles from my total of 5 marbles. Okay? Whoa, go back. Go back. All right? How how did I get that my probability was 30 over 56? Good. And could we reduce that? Yeah. I just want you to see where I'm getting these numbers, because like I said, on your homework, you're going to be asked a lot of probabilities. So I got what I found out from my combinations, and then I put it over my total number of options. Any questions on that? All right. How many different draws would contain exactly 2 red marbles? You want to share? Yeah, how'd you do it? Ideas? Ben? Good. Why are we going to have to do 3C2 and 5C1? Good. We're drawing 3 marbles, so if I draw 2 reds, that means I must draw 1 white. So I'm going to do 3C2 times 5C1, and that will get me 15. So what is the probability that I would draw exactly 2 red marbles? 15 out of 56. Okay? All right, let's look at these practice problems. 15 students are in a class and 5 are going to be giving demonstrations. How many different ways can the teacher choose the demonstrators given each condition? So your first condition, the order of the demonstrators is important. Permutation or combination? Permutation. What is it? What are we going to do? 15p5. Go ahead and calculate that, please. What do we get? 360,360. All right. Look at the next one. The order of the demonstrations is not important. Is my answer going to go up or down from the first one? Down. Why down? Yeah. The order is not important. Specifically, what are we dividing out? You're getting rid of all the repetitions. So what's different in this formula that we divide from our permutations formula? There was that extra thing in the bottom of our formula. What was that extra thing? The r factorial. What's r in this case? The 5. So I could take my permutations and divide it by 5 factorial. Or even easier, what could I do? 15 choose 5. 15 choose 5, and we will get 3,003. Okay? But I want you to understand how these guys work together. Okay? The permutations is all the options, but now once I don't care how those 5 are ordered, I divide out all the arrangements of 5. And that's where this 3,003 comes from. All right? Okay. 8 students will be drawn at random from a hat containing 14 freshmen, 15 sophomore, 8 junior, and 10 senior names. Okay. How many total different draws of 8 names are there? How would I do this? You would have to add them up, and what do you get when you add them up? 47. So I would do what? 47C8. 47 total, and I'm choosing 8 of them. So there's almost 314 million and a half ways to choose all these different names. It's quite a lot, right? Quite a lot. Okay? So, how many different draws of the 8 names would contain only juniors? 1. Why 1? Yeah, there's only 8 juniors, so there's only one way to choose all 8 of them. You could write it all out like this, but we know that anything choose 0 is just what? 1. So those all go away, and we just get 8 choose 8, which is 1. How many different draws of 8 names would contain exactly 4 juniors and 4 seniors? Would you give this one a chance, please? Exactly 4 juniors and 4 seniors. What could I do here? 8C4 times 10C4. I could do the 14C0 and the 15C0, but that's just 1. So when I go ahead and multiply 8C4 times 10C4, I will get 14,700. What is the probability that this will occur? What do I do with this number to find the probability? Put it over that really big number of total combinations. And I'm sure you could reduce that and whatnot, but the big idea I want you to get here is that we take this and we put it over our total combinations. All right, questions about combinations? Ben? Hold on. What? That probably is part of the reason, yeah, because there's so many different classes and so many different ways they could all fit in. That might be why. Any other questions?